Well, hello. Again, my name is Michael Dombach, and I'm Senior Vice President of HyperWorks. And that name is getting a general upgrade this year, which I'm going to be talking about a little bit in my slides and how it fits into Baal's introduction. So what I'm going to be starting on is how HyperMesh fits into the HyperWorks portfolio. So HyperWorks essentially is going to encompass everything, not just pre and post, but all the solver technology as well that fits into the design and simulation portfolio. What we really want to do is we really want to enable all of our customers to leverage optimization as early in the design process as possible. With the acquisition of SimSolid, which now fits under HyperWorks, our users are going to have access to these workflows as early as possible all the way through to the manufacturing side. Now, each of these technologies have a differentiator. SimSolid is obviously operating directly on CAD. If you haven't tried it, you definitely should give it a shot. That's as early as possible. Inspire and SimLab have different user bases for rather smaller models, complex assemblies, SimLab for the multi-physics. Where HyperWorks fits in, though, that's where I'm going to talk about next. So HyperMesh has been the flagship for Altair for over 30 years now. It's been the flagship of our user base and as such our revenue stream as well. And the reason it has been the flagship is because we have been solving the toughest problems across the largest range of industries. From the marine, the shipbuilding, for the aircraft carrier, to the airframes of these jet aircraft, the powertrains of each. We have natural gas turbines for power generation, steam turbines for the nuclear reactor power plant, if you will, of the aircraft carrier. And then, of course, the Jet A turbine engines that power the jets. But we span beyond that, of course. We are into satellites now and nuclear reactors. So all of these problems are all solvable with HyperWorks because of the flexibility. But also because of the value that fits under the Altair licensing system and allows our users to try all different things at relatively zero effort. So this is where HyperMesh, as it's going to be called, we're upgrading the HyperMesh name as well, and I'll talk about that later. But we differentiate ourselves from our SimLab users, our SimSolid users, and our Inspire users by handling very large and very complex finite element models. We support a collaborative environment which allows users to share these models across multi-geographical teams and multiple disciplines. Over the last 4 years, we have been, I would say, subdividing our tools into modules, or what I like to call fundamental particles. Our team has been, every time we make a new feature or spend the time on an old feature to make it a module, this really accelerates the product development of the entire suite of tools. For example, meshing, plotting, design exploration, and sketching are all modules that you're already seeing in multiple products. But the users, again, this has been going on for at least 4 years now, the users are not even aware that HyperMesh is using a SimLab feature, or SimLab is using a HyperMesh feature, or an Inspire feature. These tools are all blending together, and eventually we want to get it so you don't even switch clients. Okay, so that's the long-term goal, and for the last 4 years this modularization has been working. In fact, SimLab has been using the most modules of the Inspire team and the HyperMesh team. So they get credit for moving fast, but the code development is shared amongst all the teams. So it's benefiting everyone. And the last point I want to make on this is this not only allows us to take advantage of the strengths of each of these products, but if we have a new problem to solve, for example, we recently acquired some architectural software, and we want to be able to take and build a solution for those users from each independent module, from Inspire, SimLab, SimSolid, and HyperMesh, to make an entire workflow for that particular vertical. So that's how the modularization is helping us move faster. Another upgrade here to our infrastructure is engineering neutral entities. And what this means is we have been developing our solver templates more or less in a silo. When the Nastran template and the OptiStruct template were done, it was done at a completely different time than the Abacus one, or the Dyna one, or the Radios one, and not a whole lot of connectivity between the two. So even though we were solver neutral and that we supported as many solvers as possible, it still involved a conversion process. Now with engineering neutral entities, not only do we facilitate converting from one solver to another, because that essentially goes away, we essentially enable the PLM solution and the PDM solution to move to the cloud by moving to engineering neutral entities. So in the next few years, you're going to hear a lot of work being done on entity migration, for example. Another way where we're making this completely neutral is on the HDF5 container. So if you're not familiar, I'm going to talk about this later in some of the post section. But right now, if you save all your information, if it's not in a solver deck, it's in a HyperMesh binary. We are actually creating a common backend data model which will support an HDF5 container, which is essentially open source. So now any OEM can leverage process automation with all of HyperMesh and any third-party tool without even having to open up the client and go in and out of the database. And that lets us fit into any ecosystem, even if our competitors are involved, okay? And that allows flexibility and scalability for our end users. And then lastly, on the scalable infrastructure, we're migrating over to Python. And this is a huge benefit of moving to what we on the development side call one process, which is related to removal of the panels. Now we're finally going to be able to deliver some Python APIs, which will connect the dots to multiple clients. Because as we know, people coming out of uni already know Python, and it's the language moving forward. On the cloud, of course, Altair has its own cloud offering, but our team is very proud to interact with multiple versions of our customers' clouds. Again, this fits into our flexibility. We can handle variations going from a CAD base like Teamcenter all the way to defense customers' isolated file-based systems. So being able to do that is enabled through some of these segmented workflows. For example, parts and subsystems, being able to pull different segments of a very complex assembly and move it back and forth to a PLM system, even if that PLM system is not an Altair PLM system. And those containers are critical for moving to this collaborative workflow. AI, it's really hot right now, obviously. Everybody wants to know where AI fits in our picture. I've got a slide later, but we've got it in the pre-side to reduce lead time reduction for part recognition, and also on the post side for sorting out lots of results. But we also are integrating, as Bal had mentioned, with our data science team. And we're leveraging those modules as much as possible on our side of the fence as well. So this convergence of us is really happening everywhere and at all levels at Altair. So that was some of the vision of where we're going, and what I want to get into a little bit is more of the motivation of why we switched to the interfaces. I want to date ourselves a little bit here. This is an old video that we used a while back that I thought was relevant here on the product evolution. And this shows where the interface had been since version 1, which, by the way, predates the modern mouse. So that is how old our panels are, okay? And we have gone through some drastic changes over the last 30 years. And what we've learned is we home grew our own user interface with Inspire. And we took those lessons learned and we applied it across everything in the HyperWorks portfolio. So I added another old slide that I think is also relevant. This slide is from 2017, where our then CTO, James Dagg, talked about how we were migrating all of our tools to this Unity interface. And this gives us a lot of development for free. For example, SimLab got there first. Okay, during the SimLab acquisition, it didn't take them very long at all to migrate over to what was then called the Inspire interface, because that's where we birthed it. But HyperWorks had the largest momentum. We had the largest user base. We also had the largest revenue. So movement was relatively slow, and we had to be very careful while doing it. But we're finally there, and this release, in fact, just last week, was the last build on the development side where there was a panel. Okay, so as of last week, the panels are gone, and I'm going to talk about what that means for people that are still on the panels later. But James's vision is still valid. All of the products have the same look and feel. So that's done. The second phase of James' vision is to connect the dots in the back, and then the third phase of that vision is to make it so you can't even tell what product you're using. And as I mentioned earlier, that's already true. Okay, you're already using SimLab in HyperMesh, you're already using HyperMesh and Inspire and SimLab, etc. You just don't even know it. Okay, so on this piece, I want to highlight here where Inspire was born. Inspire was really a ground-up version of how to make a usable interface, and I'm not going to go into the details of this interface. Instead, I'm going to tell a story that happened in about 2019. This customer, they were all veterans, okay, and they had a veteran of HyperStudy, a veteran of HyperMesh, and another veteran of HyperMesh that specifically was a HyperMorph veteran. 3 very skilled engineers in HyperWorks tools at this particular company. And Inspire was just delivered. Okay, they hadn't used it. They weren't going to try it new. Instead, they brought the intern in for the summer. And this intern did not get sent to training. This intern was just pointed to self-based stuff. Okay, and this intern, with the design exploration that is in Inspire, was able to mesh, morph, do a DOE, and do an optimization on that same assembly during his tenure just for that summer. And he basically did the entire job of the 3 veterans of the old tool, okay? So this was a critical learning moment, okay? So obviously, you know, people that are new are gonna be able to pick it up quicker, but I think the lesson that needs to sink in is the integrated workflows and the leveraging of HyperStudy as a module in the new interface, and leveraging HyperMesh and HyperMorph as new ribbon bar workflows, which I'm going to talk about next. Actually, you know what? I'm going to say it here too. HyperMorph, which I believe Richard Boyd is going to be presenting later. Where is he? Richard, there he is. He's going to be presenting a HyperMorph later. This is a poster child of this interface, in my opinion. HyperMorph has had a load of features since the beginning of time, okay, since 6.0, and it got really good in 8.0. The problem with HyperMorph was always the depth of the panels. You really needed to be an expert user to leverage the functionality of HyperMorph. I mean, the constraints that are available, how to apply those constraints, some of those features are 6 panels deep, and you actually need to know they exist to get there. And now, as I had mentioned in the previous example with Inspire, the HyperMesh workflows are now all ribbon-based. So now learning how to use HyperMorph is more adaptable and self-discoverable, which is what we want to do. Okay, so we have, since 2019, we have had the new interface. Okay, so if you haven't used the new interface, you really have been missing out on a lot of features over the last 4 years. And that's because our development team has been focusing on adding these new features in the new interface alone. And since 2019, the classic panel type interface has essentially been kind of being kept alive in maintenance mode and gets features for free that come with the browsers and whatnot. But workflows like the concept and optimization, design space, sketching, the section libraries, the skeleton modeling, all of these concept and optimization workflows are only available in the new interface. And they have been going on, again, since 2019. So if you haven't opened up that new interface since 2019, you're missing a good 4 years of development in this particular area. I also want to include the model build and assembly, which has gone some great strides here, and I'm hoping that Darren will allude to some of these in his next presentation. But there are multiple steps here. Migrating from a component to the parts-based workflow and the subsystem-based workflow is really going to facilitate, as I mentioned earlier, a modular, collaborative work environment, but also enables us to move to the cloud, into our own cloud-based PLM system. Right now you can use HyperMesh and HyperWorks in Altair 1, but to have a client-based HyperWorks connect to an Altair 1 PLM system, that's going to be enabled by parts and subsystems workflows. So definitely take a look at this, and I think Greg and Tim will be talking about model assembly and how we connect these independent subsystems and parts later. One other piece here, this is another that I used in my intern story at this particular company in 2019. Design exploration is really a modularization of our HyperStudy tool, and that enables optimization in many different ways. So I'm very proud of this workflow in HyperMesh. However, because we made it as a module from the ground up, leveraging HyperStudy, Inspire now has this for free. It's the exact same code, just now baked into the same front end. So Inspire can use it in entities, and soon SimLab will be able to leverage the same. So these are just some examples of workflows that have been going on for 4 years that are only in the new interface. AI and HyperMesh. I mentioned this previously, that this is something that our customers constantly ask us, how are we leveraging AI? How are we leveraging AI? It's definitely a buzzword nowadays, and now that we're in data analytics, we have it everywhere. And I just want to give you a couple examples. This is what we call our engineering data science area. So hopefully most of you are familiar already with what HyperStudy can do. But we also are using Design AI for the cloud for doing sorting. On the pre-processing side, we're using AI to cluster our parts, find symmetric parts, do the matching, and then sort them depending on batch mesh criteria. So lead time reduction on pre-processing, and also lead time reduction on the post-processing, taking a large 2,000 run DOE, letting an AI classify these particular parts into little clusters. So now instead of a user post-processing thousands of runs, they're post-processing 20 runs. Okay, so lead time reduction on the post. And I just have a couple examples here on this. There's a whole presentation just on this, but I just wanted to show some classification parts. This is a really nice video on how that's working. And then this is a slide on the clustering, where you have thousands of runs for DOE, and now the engineer is able to post-process only those where the rail crushes at this particular initiator and nothing else. Okay, so I did want to talk about, I alluded to this in the vision, but I want to talk about how we're doing it on the back end. James Dagg's vision was not only to just make them all look and feel the same in the front, but he wanted them all to be the same client. Okay, so that's where we're going. That's phase 3 of the vision. Phase 2 is to connect the back end, to make all the tools talk to each other. So even if you don't have the module, it won't matter. So that's what we're doing next. So this was a repeat of his slide for how the front end is working. Check, done. Now, how are we doing it on the back? So previously, we would have to connect all the dots with all of our tools. So we have a large suite of tools, and as Bal had alluded to, we keep acquiring more. All right, and every time we do a new acquisition, we need to get that team on board to moving to this interface, which is an eventuality for all the teams. So we have tools in the design space. We have tools in the CE, process and optimization space. Obviously, that's our main event. System modeling, multi-physics, and now data analytics. So if you take all of these tools and you try to make them talk to each other, you're working with an import template, an export template. You may be parsing an XML file or parsing a bulk data file or a CSV. A lot of these involve a lot of connecting the dots between all the tools. And unfortunately, this is usually done by very expensive people. Typically, it's a methods team that are dedicated to this, and it's their full-time job to make sure there's good methods development and process flow across a large suite of tools. So this is how we're fixing this problem. We're creating a common backend to make all the tools talk with the same APIs to the same backend. And this is what we call our common backend data model. Okay, marketing obviously hasn't given us input yet on what we're going to call that. All right, so it's going to be named something else eventually. But moving all this data back and forth will have the same language and the same file structure, which again alludes back to moving to engineering neutral entities that I showed in my third or fourth slide. So we do this through the metaclass descriptor interface, or the MDI. And again, marketing hasn't had a say, so this is pure dev slide here. But making all these talk to each other has several advantages. So we've got modularization. We already talked about how the modularization is helping all the products. Now having the modularization, it doesn't even need to be adapted completely for this to work. So you can reuse all these functionalities across them without having to even include that particular module. And then definition of neutral libraries and the software components. This is really the engineering neutral entity, saving everything in a part and saving everything in a subsystem, or saving a boundary condition or a result as a scalar, vector, and a tensor rather than a pressure or a temperature. And then common Python APIs. As I mentioned in one of my previous slides, Python is the future for connectivity across multiple products, including our competitors' products. So all of this will be done with Python APIs. And of course, this enables cloud deployment. Any entities that we move to this backend, Altair 1 will automatically be able to read and write. So we don't necessarily have to do special code development to get Altair 1 to work if it can read it already for free. Okay, so just to wrap up, I have a few details that usually are like a frequently asked questions that I get, so I'm going to wrap that up with some numbers. People always ask about the Python roadmap, so I've included that here. I'm not going to go through everything on Python, but if you want, Stafuka, who you can raise your hand here, everybody can go to this guy for their questions on Python. And one thing I do want to mention is the one process branch to finally get rid of the panels is what's enabling us to accelerate the Python development. Okay, so that's an important piece. Everybody wants Python, and you can't have them both ways. Here's a timeline. It's essentially completed, and I'm going to zoom in on it soon. So I mentioned before that this transition to the new interface has been going on since 2019. But the deprecation of the panels has only been going on for this last release. So from 2022.0 to 2022.3, we've been gradually deprecating panels that are obsolete with the new interface. However, it's important to know that even though there aren't any panels anymore in version 2022.3 as of last week, we are still going to be maintaining the last version with panels. So 2022.3, which is literally going to be released the first or second week of April, that will be maintained, and we're going to be patching it for at least a couple years. So I'm projecting out till 2025. This is a process we normally do anyway. We have customers that use old versions because their IT department doesn't want them to patch it every release, so they schedule every couple years. So having to hotfix an old release is nothing new to us. So I'm just trying to reassure you that if you do need those panels for some reason, 2022.3 will be available, and it will be hotfixed, and will even include new CAD packages when it makes sense for 2022.3. Okay, so moving forward, this is where we're at in the timeline. Literally next month, the last version of panels will be released, 2022.3, and then this August, even though we've been pretty good at maintaining our timeline for the last 4 years, this August we're going to be a little bit flexible because we basically had a point of no return by getting rid of the panels last week, and we want to make sure that's done and done right, and we're not going to release it until it is. So it might be a little bit flexible on the first week of August. But my team will do their best to make sure it's on time. So anyway, I want to repeat because this is important. We will be packaging and hotfixing 2022.3, last version of panels, for at least a couple years while people transition finally to the new. And then also another question that I get asked a lot are we're doing entity migrations, which I alluded to before with engineering neutral entities. Some of the workflows that depend on these entities, they really have nothing to do with the GUI changeover. Okay, these are just a regular evolutionary process to migrate to the cloud. Okay, so it has nothing to do with the GUI. It just happens to be going on at the same time. Okay, and then lastly, I want to bring up the slide that Bal had mentioned. Marketing is giving an upgrade to some of the naming. Altair, through all these acquisitions, has acquired technologies that fit under one of these three big trees at the company. And the brands that really stick out are the winners here. So the brands that we want to keep are HyperMesh and HyperWorks. So HyperWorks is getting an upgrade. Everything under design and simulation will be called HyperWorks. So everything that's in SimSolid, FICO, any of our solvers, they will all fall under HyperWorks. It's no longer going to be pre and post processing moving forward. Okay, they're all going to be labeled HyperWorks. And then HyperMesh is going to essentially get the upgrade to be what you now think of as HyperWorks. So those brands are getting an upgrade. So HyperWorks will be our platform for all modeling and simulation, and then the desktop will become HyperMesh. So that naming is still in the works, but I just wanted to give you an idea that that's coming, so stay tuned for that upgrade in the tree. And then I'm just gonna wrap up with our doors are open to flexibility. We have been open architecture, and we have been trying to proliferate all of our users across all the products with our patented licensing system. That's where we feel the future adds value to all our users and IT departments. We also allow you to be scalable and flexible. So that's where we feel the future is. Scalable, flexible, and value. So that concludes my presentation, and only forward.